Right now, as you're watching this, billions of quantum events are happening in your brain, each one supposedly occurring in a sequence we call time. But what if I told you that this sequence, this flow from past to future that feels so real, so undeniable, might be the universe's greatest illusion? What if time itself is nothing more than a story we tell ourselves to make sense of existence? Every second that passes feels real. Every tick of the clock seems to move us forward through something we call time. But deep in the mathematics of our universe, in the strange world of quantum mechanics and the mind-bending predictions of relativity, something incredible emerges. Time might not be flowing at all. It might not even exist the way we think it does. And by the end of this journey, you'll see reality in a completely different way. You'll understand why some of the greatest minds in physics believe that everything you think you know about time is wrong. Think about this moment right now. You have memories of the past, experiences that feel like they happened before this instant. You have expectations about the future, things you believe will happen after this moment ends. This creates what feels like a river of time flowing from past through present into future. But here's the problem that's been haunting physicists for over a century. When we look at the fundamental equations that govern our universe, time doesn't behave the way it feels like it should. Einstein's theory of relativity showed us that time can stretch and compress. It can slow down when you move fast or get close to massive objects. Two people can disagree about what happened first, and both can be right. Time isn't the steady, universal flow we experience in our daily lives. But it gets stranger. In quantum mechanics, the math that describes the smallest particles in existence, time becomes even more mysterious. Particles can seem to influence each other instantly across vast distances. Quantum events appear to happen in ways that seem to ignore our normal understanding of cause and effect. The future can seem to influence the past. And then there's the deepest mystery of all. When physicists try to unify relativity and quantum mechanics, when they attempt to describe what happens at the very foundations of reality, time often disappears from the equations entirely. Not just changes, not just gets weird, but vanishes completely. As if the universe, at its most fundamental level, knows nothing about time at all. This isn't just an abstract mathematical curiosity. This touches the core of what it means to be human. If time isn't real, what does that mean for our memories, our hopes, our entire experience of being alive? How can we make sense of a universe where the most basic thing we experience might be an illusion? The Einstein revolution. Let's start with what Einstein discovered, because it changed everything we thought we knew about time. Before Einstein, people believed in something called absolute time. Isaac Newton described it perfectly. Time was like a cosmic clock, ticking away steadily throughout the universe. No matter where you were, no matter what you were doing, time passed at exactly the same rate for everyone. Einstein proved this was wrong. Not just slightly wrong, but fundamentally, completely wrong. Time, he showed us, is relative. It depends on how fast you're moving and how strong the gravity is around you. This isn't just theory. We can measure it. GPS satellites have to account for the fact that time runs slightly faster in space than it does on Earth's surface. The clocks on those satellites gain about 38 microseconds per day compared to clocks on the ground. But here's where it gets really mind-bending. Einstein showed that past, present, and future aren't fixed, universal categories. Imagine two events happening in the universe, a star exploding in one galaxy and a planet forming in another. You might see the star explode first, then the planet form. But someone moving at a different speed in a different reference frame might see the planet form first, then the star explode. Both of you are right. There's no universal now that spans the entire universe. This revelation created what physicists call the block universe theory. Picture the universe as a vast four-dimensional block, where 3 dimensions are space and 1 is time. Every moment that has ever happened or ever will happen exists simultaneously in this block. The past hasn't disappeared, it's still there, just in a different location in the block. The future hasn't happened yet from our perspective, but it already exists in another part of the block. From this view, time doesn't flow. We don't move through time like a boat moving down a river. Instead, we exist as four-dimensional objects stretched across the time dimension of the block. Your birth, your childhood, this moment right now, and your death are all equally real, all existing simultaneously in the block universe. But if that's true, why do we experience time as flowing? Why does it feel like we're moving from past to future? The answer might lie not in the nature of time itself, but in the nature of consciousness and memory, the quantum mystery. Now let's dive deeper into the quantum realm, where time becomes even stranger. In the world of the very small, particles behave in ways that seem to defy our normal understanding of time and causality. Consider quantum entanglement. When two particles become entangled, they remain connected in a way that measuring one instantly affects the other, no matter how far apart they are. Einstein called this spooky action at a distance, because it seemed to violate the rule that nothing can travel faster than light, including information. But experiments have confirmed that entanglement is real. Particles can be entangled across vast distances, and when you measure one, the other immediately responds. This happens faster than light could travel between them. It's as if the particles exist in a realm where distance and time don't work the way we expect. Then there's the quantum measurement problem. In the quantum world, particles exist in what we call superposition. They can be in multiple states simultaneously until they're observed. Schrödinger's famous cat thought experiment illustrates this perfectly. A cat in a box with a quantum device that might or might not poison it exists in a superposition of being both alive and dead until someone opens the box to observe it. But here's the strange part. Some interpretations of quantum mechanics suggest that the act of observation doesn't just reveal the state of the particle, it actually determines it. The future measurement seems to reach back in time to determine what the particle was doing in the past. Cause and effect, the foundation of our temporal understanding, breaks down at the quantum level. There's even stranger evidence from quantum delayed choice experiments. In these experiments, scientists can decide how to measure a photon after it has already passed through a detector. Amazingly, the photon seems to know ahead of time how it will be measured and behaves accordingly. It's as if the future measurement influences the past behavior of the particle. Some physicists interpret this as evidence that time at the quantum level doesn't work the way we think it does. Instead of a linear progression from past to future, quantum mechanics might reveal a reality where all moments exist simultaneously, where the future can influence the past, where time is more like space, a dimension you can move through in different directions. The thermodynamic arrow. But if time might not be fundamental, why do we experience it as flowing in one direction? Why do we remember the past but not the future? Why do broken eggs never spontaneously reassemble? The answer might lie in thermodynamics and something called entropy. Entropy is a measure of disorder in a system. The second law of thermodynamics states that entropy in a closed system always increases over time. This means that systems naturally move from ordered states to disordered ones. Ice melts, buildings crumble, people age. This gives us what physicists call the thermodynamic arrow of time, the direction in which entropy increases. But here's the crucial insight. This arrow of time might not be fundamental to the universe. It might just be a statistical tendency, a consequence of the particular conditions our universe happened to start with. If the universe began in a very low entropy state, very ordered, very organized, then it would naturally evolve toward higher entropy states as time passes. This low entropy beginning is sometimes called the past hypothesis. It suggests that the reason we experience time as flowing from past to future is simply that the universe happened to start in a highly organized state and has been becoming more disorganized ever since. But why did the universe start in such an ordered state? Some physicists suggest that there might have been countless universes, each with different starting conditions. We happen to find ourselves in one where entropy was initially low because those are the only universes where complex structures like galaxies, stars, planets, and life could form. In universes that started with high entropy, nothing interesting would happen. Time, in a sense, would be meaningless. This leads to a profound possibility. Maybe time's arrow is just an accident of our particular cosmic history. In other regions of a larger multiverse, time might flow in different directions, or not at all. The flow of time that feels so fundamental to our existence might be nothing more than a local, temporary phenomenon. Consciousness and the illusion of now. This brings us to perhaps the deepest question of all. What creates our experience of now? If the block universe theory is correct, if all moments exist equally in a four-dimensional space-time, why do we feel like we're experiencing one moment at a time? Why does consciousness seem to move through time like a spotlight, moving across a landscape? Some neuroscientists and philosophers suggest that our sense of flowing time is created by the way our brains process information. Memory allows us to compare our current state with previous states, creating the illusion of change and flow. But each moment of consciousness, each now that we experience, might be equally real and equally present in the block universe. Think about it this way. When you remember yesterday, you're not actually accessing yesterday itself. You're accessing patterns in your brain that were created by yesterday's experiences. Those patterns exist in your present moment. Similarly, when you anticipate tomorrow, you're not somehow reaching into the future. You're creating patterns in your present moment based on your expectations. This suggests that the flow of time might be entirely psychological. Each moment of consciousness contains references to other moments, memories of the past, expectations of the future, but exists only in its own present. There's no actual movement from one moment to another, just a series of self-contained conscious experiences, each one feeling like it's now when it occurs. Some physicists and philosophers go even further. They suggest that consciousness itself might be the key to understanding time. Maybe time doesn't create consciousness, but consciousness creates our experience of time. In this view, time is not a fundamental feature of the universe, but an emergent property of complex information processing systems like brains. The holographic universe and emergent time. Recent developments in theoretical physics have opened up even more radical possibilities about the nature of time. One of the most intriguing is the holographic principle, which suggests that all the information in a volume of space can be encoded on its boundary, like a hologram. This principle emerged from studying black holes. Stephen Hawking showed that black holes emit radiation and eventually evaporate. But this created a paradox. When a black hole evaporates, what happens to the information that fell into it? The holographic principle suggests that this information never actually falls into the black hole but remains encoded on its surface. If the holographic principle applies to the entire universe, it could mean that all of three-dimensional reality, including time, is actually encoded on a two-dimensional boundary. In this view, time might be an emergent property, something that appears at macroscopic scales but doesn't exist at the fundamental level. This connects to other ideas about emergent time in quantum gravity theories. In these theories, space-time itself emerges from more fundamental quantum information processes. Time, rather than being a stage on which events happen, would be a pattern that emerges from the interactions of quantum information. Loop quantum gravity, one approach to unifying relativity and quantum mechanics, suggests that space and time are made up of discrete units, quantum loops. At the smallest scales, time wouldn't be smooth and continuous but granular, made up of tiny, indivisible moments. This could mean that at the very foundation of reality, time is not flowing but jumping in discrete steps. String theory offers another perspective. In string theory, our four-dimensional space-time might be just one slice of a higher dimensional space. From the perspective of these extra dimensions, all of time might be visible simultaneously, like looking at a loaf of bread and seeing all the slices at once. The multiverse and eternal time. These ideas about the nature of time connect to even grander theories about the structure of reality itself. If time is not fundamental, if it emerges from deeper quantum processes, what does this mean for the universe as a whole? Some cosmologists propose that our universe is just one bubble in an infinite multiverse. In this eternal inflation theory, new universes are constantly being created through quantum fluctuations. Each universe has its own arrow of time, its own history, its own physical laws. From the perspective of the multiverse as a whole, time might be meaningless. All possible histories exist simultaneously across different universe bubbles. This leads to profound philosophical questions. If all possible histories exist somewhere in the multiverse, do our choices matter? If every decision branches into multiple universes, creating different timelines, what does it mean to talk about the future? Some physicists suggest that we need to abandon our usual notions of time entirely when thinking about the multiverse. Instead of thinking about the multiverse evolving in time, we might need to think about it as a timeless mathematical structure that simply exists, containing all possible realities simultaneously. This connects to what some philosophers call the mathematical universe hypothesis, the idea that reality is mathematics. In this view, time is not something that exists independently, but is simply one aspect of the mathematical structure that describes reality. Our universe, with its particular arrow of time and its specific history, is just one mathematical object among infinitely many others. Implications for human existence. If time is indeed an illusion, what does this mean for human life and meaning? This question touches the very core of what it means to be alive and conscious in this universe. On one level, it might not change anything at all. Even if time is emergent or illusory, we still experience it as real. We still age, we still remember the past and anticipate the future. We still make decisions based on our understanding of cause and effect. The practical aspects of human life continue regardless of time's ultimate nature. But on a deeper level, understanding time as an illusion could radically change how we think about existence. If all moments exist equally in a block universe, then every moment of joy, love, discovery, and wonder is eternal. Your childhood, your first love, the birth of your children, moments of profound beauty or insight. All of these exist permanently in the structure of space-time. But this also means that all moments of suffering exist eternally too. Pain, loss, disappointment, and death are all equally permanent features of the block universe. This presents both comfort and challenge. Comfort in knowing that good moments never truly pass away. Challenge in accepting that difficult moments are also eternal. Some find this perspective liberating. If the future already exists in some sense, if our entire life story is already written in the fabric of space-time, it might free us from anxiety about what's to come. Others find it disturbing, feeling that it undermines free will and personal responsibility. But perhaps these concerns miss the point. Even in a block universe, even if time is emergent, we still make choices. We still have experiences. We still love and create and discover. The fact that these choices and experiences might exist timelessly doesn't make them less real or less meaningful. It might make them more so. The search for a theory of everything. The mystery of time is intimately connected to the greatest challenge in modern physics, developing a theory of everything that unifies all the fundamental forces and explains the deepest nature of reality. Currently, we have two incredibly successful theories that seem incompatible. General relativity describes gravity and the large-scale structure of space-time with incredible precision. Quantum mechanics describes the other three fundamental forces and the behavior of matter and energy at the smallest scales with equal precision. But when we try to combine them, the mathematics breaks down. This breakdown happens most dramatically at the very beginning of the universe, in the first moments after the Big Bang and at the center of black holes. In these extreme conditions, both quantum effects and gravitational effects are important, but our current theories can't handle both simultaneously. Many physicists believe that resolving this conflict will require a fundamental reconceptualization of space and time. Some approaches, like loop quantum gravity, suggest that space and time are granular at the smallest scales. Others, like string theory, propose that space and time emerge from more fundamental mathematical structures. A few physicists go even further, suggesting that time might be completely absent from the most fundamental description of reality. Carlo Rovelli, one of the founders of loop quantum gravity, argues that time is not a universal feature of the universe, but a property that emerges when we describe the universe from a particular perspective. In this view, the fundamental equations of physics would be timeless. Time would appear only when we describe the universe from the perspective of particular observers, in the same way that concepts like left and right only make sense from particular perspectives, but don't exist in the fundamental description of space. This could resolve many of the puzzles about time that have troubled physicists. If time is not fundamental but emergent, then there's no contradiction between the smooth, continuous time of relativity and the granular, probabilistic time that emerges from quantum mechanics. They would be different aspects of the same underlying timeless reality, ancient wisdom and modern physics. Interestingly, these modern scientific ideas about the illusory nature of time echo insights from ancient philosophical and spiritual traditions. Buddhist philosophy has long taught that the sense of a continuous, flowing self moving through time is an illusion. Hindu philosophy speaks of Maya, the cosmic illusion that makes the eternal appear temporal. The ancient Greek philosopher Parmenides argued that change and motion are impossible, that reality is a timeless, unchanging whole. His student Zeno created famous paradoxes that seem to show the logical impossibility of motion and change. These ideas were dismissed for centuries as philosophical curiosities, but they bear striking resemblances to modern ideas about the block universe and emergent time. Plato distinguished between the world of appearances, where things seem to change and flow in time, and the world of forms, where perfect eternal truths exist timelessly. This distinction mirrors the modern scientific distinction between our everyday experience of time and the timeless mathematical structures that might underlie reality. Even more striking are parallels with mystical traditions across cultures. Mystics have long reported experiences of transcending time, of experiencing all moments as simultaneously present, of seeing the eternal nature of reality behind the veil of temporal appearance. These reports, once dismissed as mere hallucinations or wishful thinking, might actually be glimpses into the deeper nature of reality that physics is now uncovering. This doesn't mean that ancient wisdom traditions were doing physics, or that modern physics proves spiritual beliefs, but it suggests that the human mind, in its deepest contemplations, has always sensed something strange about time, something that doesn't quite fit with ordinary experience. The future of time. Where does this leave us? What does the future hold for our understanding of time? As experimental techniques become more sophisticated and theoretical frameworks more developed, we may finally be able to test some of these ideas about the nature of time. Quantum gravity experiments might reveal whether space and time are truly continuous or made up of discrete units. More precise tests of quantum mechanics might show whether the quantum measurement process really involves backward in time influences. Cosmological observations might reveal whether our universe is just one bubble in a larger multiverse where time works differently. Advances in neuroscience and consciousness research might help us understand how the brain creates our sense of temporal flow and whether this sense is fundamental to consciousness or just one way that information can be processed. Computer simulations of quantum gravity theories might show us what reality looks like when time is emergent rather than fundamental. These simulations could reveal new ways of understanding how the smooth time of our experience emerges from the granular, probabilistic processes at the quantum level. But perhaps the most profound changes will come not from new experiments or theories, but from new ways of thinking about time and existence. If time really is emergent or illusory, this could fundamentally change how we understand consciousness, meaning, death, and the purpose of life, living without time. So, how do we live with the possibility that time might not be real? How do we find meaning and purpose in a universe where past, present, and future might all be equally valid, where the flow of time might be nothing more than a persistent illusion created by our brains? Perhaps the key is to recognize that even if time is not fundamental, it is still real for us. Our experience of temporal flow, of memory and anticipation, of growth and change remains valid even if it doesn't reflect the deepest nature of reality. A dream is not less meaningful to the dreamer because it's not happening in external reality. In fact, understanding time as emergent might make our experiences more precious, not less. If our consciousness creates the experience of temporal flow, then we are active participants in creating reality, not just passive observers of it. Our choices, our attention, our consciousness itself might be fundamental to bringing time into existence. This perspective might also help us deal with some of the most difficult aspects of human existence. If time is emergent, if all moments exist equally in some deeper reality, then perhaps death is not the end, but simply a boundary of our particular temporal experience. The love, beauty, and meaning we create continue to exist in the eternal structure of reality, even if our personal experience of temporal flow comes to an end. It might also change how we think about moral responsibility and personal growth. If the future is not yet determined, if it emerges from quantum processes that are inherently probabilistic, then our choices really do matter. We are not simply following a predetermined script, but actively participating in creating the reality we inhabit. Here's the moment where everything comes together, where all these abstract ideas about time suddenly become personal and immediate. Right now, as you're processing these words, as your consciousness experiences this present moment, You are participating in the deepest mystery of existence. Your brain is taking quantum information from billions of neural events and weaving them together into a coherent stream of consciousness. That stream feels like it's moving through time, but it might actually be creating time. Each moment of awareness might be bringing a new slice of reality into existence, adding another layer to the infinite block universe. Think about what this means. You are not just observing reality, you are helping to create it. Your consciousness, your ability to experience one moment after another, might be one of the fundamental forces that brings time into being. Without consciousness, without beings like you who can experience temporal flow, time itself might not exist. This is not just philosophy or abstract physics. This is about you, right now, in this moment. As you understand these ideas, as you contemplate the possibility that time is not fundamental, you are doing something extraordinary. You are using your mind to transcend the limitations of your ordinary experience and glimpse the deeper nature of reality. And perhaps that's what consciousness is for. Perhaps that's why the universe evolved beings capable of asking these questions. Not just to observe reality, but to understand it, to see through the illusions of everyday experience and perceive the eternal, timeless truth that lies beneath. You are part of the universe becoming aware of itself. You are time becoming conscious of its own nature. In this moment of understanding, the boundary between observer and observed, between time and timelessness, dissolves. You are not in the universe. You are the universe awakening to its own deepest mysteries. We've journeyed together through some of the most profound ideas about the nature of time and reality. We've seen how Einstein revealed that time is not absolute but relative, how quantum mechanics suggests that cause and effect might not work the way we think, how thermodynamics might explain why time seems to flow in one direction. We've explored the possibility that time is not fundamental to the universe, but emergent from deeper quantum processes. We've considered how consciousness might create our experience of temporal flow, how the multiverse might contain all possible timelines simultaneously, how ancient wisdom traditions anticipated modern scientific insights about the illusory nature of time. Most importantly, we've seen how these ideas are not just abstract theories, but revelations about the nature of your own existence. If time is emergent, if consciousness creates temporal flow, if all moments exist eternally in a block universe, then you are not just a temporary arrangement of matter moving through time. You are an eternal part of the fabric of reality itself. The question of whether time is real turns out to be a question about the deepest nature of existence, consciousness, and meaning. It challenges us to see beyond the ordinary experience of daily life and glimpse the extraordinary truth that might lie beneath. Whether time is fundamental or emergent, real or illusory, the mystery of temporal experience remains one of the most profound aspects of being human. It connects us to the deepest questions about reality and our place within it. And perhaps that's exactly as it should be. The mystery of time keeps us wondering, keeps us searching, keeps us growing in our understanding of ourselves and our universe. The clock might be ticking, or it might not. Time might be flowing, or it might be standing still. But the wonder, the curiosity, the magnificent human capacity to ask these questions and seek these answers, that is real, that is eternal. That is what makes us conscious beings in this extraordinary cosmos. If this journey through time and reality expanded your mind, subscribe for more cosmic mysteries that will change how you see everything.